This is a continuation from part 1, where fundamentals were presented and how determining the two numbers such that their sum and product are equal to a given number enables to factorize a quadratic expression. In the quest to find out why some quadratics could not be factorized using this method was stated.
Let us consider the expansion of the product a plus b into c plus d. Now, as is shown, a plus b into c plus d is equal to a into c plus b into c plus a into d plus b into d. Substitute the following values: a equals x, b equals y, c equals x, and d equals y. Hence, x plus y into x plus y is equal to x squared plus 2xy plus y squared. Therefore, x plus y whole thing squared is equal to x squared plus 2xy plus y squared. Let us consider the expansion of the product a minus b into c minus d. Now, as is shown, a minus b into c minus d is equal to a into c minus b into c minus a into d plus b into d. Substitute the following values: a equals x, b equals y, c equals x, and d equals y. Hence, x minus y into x minus y is equal to x squared minus 2xy plus y squared. Therefore, x minus y whole thing squared is equal to x squared minus 2xy plus y squared. Let us consider the expansion of the product a plus b into c minus d. Now, as shown, a plus b into c minus d is equal to a into c plus b into c minus a into d minus b into d. Now let us substitute the following values: a equals x, b equals y, c equals x, and d equals y. Hence, the product becomes x plus y into x minus y, and its expansion would yield x squared minus y squared. Therefore, x plus y into x minus y is equal to x squared minus y squared. Summary of the important identities. Square of a sum is equal to sum of squares and twice the product added. That is, x plus y whole thing squared is equal to x squared plus y squared plus 2xy, or written in the usual order x squared plus 2xy plus y squared. Square of a subtraction is equal to the sum of the squares and twice the product subtracted. That is, x minus y whole thing squared is equal to x squared plus y squared minus 2xy, written in the standard order x squared minus 2xy plus y squared. The difference of squares is equal to the product of the sum and the difference. That is, x squared minus y squared is equal to x plus y into x minus y.
In the original question, factorization of x squared plus 5x plus 4 was cited. Instead of the same, let the example be x squared plus 30x plus 225. We note that the last monomial of the trinomial is 225, which is the square of the half of the coefficient of the middle monomial. Coefficient of the x term is equal to 30. Half of the same is equal to 15. Square of the above is equal to 225. Hence, x squared plus 30x plus 225 is equal to x plus 15 whole thing squared. Of course, if one were to find the two terms such that the sum is 30 and the product is 225, then the terms are 15 and 15. Let the example be x squared minus 60x plus 900. We note that the last monomial of the trinomial is 900, which is the square of the half of the coefficient of the middle monomial. The coefficient of the x term is minus 60. Half of the same is equal to 30. Square of the above is equal to 900. Hence, x squared minus 60x plus 900 is equal to x minus 30 whole thing squared. Of course, if one were to find the two terms such that the sum is minus 60 and the product is 900, then the terms are minus 30 and minus 30. Examine the following. X squared plus 6x plus 9. X squared minus 12x plus 36. X squared plus 14x plus 49. X squared minus 16x plus 64. Hence, x squared plus 6x plus 9 is equal to x plus 3 whole thing squared. X squared minus 12x plus 36 is equal to x minus 6 whole thing squared. X squared plus 14x plus 49 is equal to x plus 7 whole thing squared. X squared minus 16x plus 64 is equal to x minus 8 whole thing squared. In each of the examples, the last monomial of the trinomial is the square of the half of the coefficient of the middle monomial. If alpha stands for a constant value, then the factorization of the above expressions result in the form x plus or minus alpha whole thing squared, noting that x plus or minus alpha whole thing squared is equal to x squared plus or minus 2 alpha x plus alpha squared. Recall the important identity x squared minus y squared is equal to x plus y into x minus y. Now examine the following. X squared minus 81, x squared minus 625, x squared minus 289. Note that 81 is the square of 9, 625 is the square of 25, 289 is the square of 17. Hence apply the identity following are the factors. Numerical application, if you are asked to calculate 101 into 99, the answer is 101 into 99 is equal to 100 plus 1 into 100 minus 1, which is equal to 100 squared minus 1 is equal to 9999. Another example of using the difference of squares is the factorization of a squared plus b squared minus c squared plus 2ab. Noting that a plus b whole thing squared is equal to a squared plus 2ab plus b squared, the given expression, grouping in terms of purple together, a squared plus b squared minus c squared plus 2ab is equal to a plus b whole thing squared minus c squared. Observing that the result is a difference of squares, a plus b whole thing squared minus c squared is equal to a plus b plus c into a plus b minus c. Hence, a squared plus b squared minus c squared plus 2ab is equal to a plus b plus c into a plus b minus c. Question. Factorize p to the power 4 plus p squared q squared plus q to the power 4. Answer. Now add the term p squared q squared and subtract the same to maintain the equality. Therefore, p to the power 4 plus p squared q squared plus q to the power 4 is equal to p to the power 4 plus 2p squared q squared plus q to the power 4 minus p squared q squared, which is equal to p squared plus q squared whole thing squared minus pq whole thing squared. And applying the difference of squares, p squared plus q squared plus pq into p squared plus q squared minus pq. Therefore, p to the power 4 plus p squared q squared plus q to the power 4 is equal to p squared plus q squared plus pq into p squared q plus q squared minus pq. The lesson is manipulate terms so that a difference of two squares is made out. Let us bear in mind the important lesson. Manipulate terms so that a difference of two squares is made out. Now, can I apply the lesson in factorizing x squared plus 6x minus 7? Yes, of course. Note the coefficient of the x term as 6. The square of half of it is 9. Hence, x squared plus 6x plus 9 is equal to x plus 3 whole thing squared. Therefore, x squared plus 6x minus 7 is equal to x squared plus 6x plus 9 minus 16, which in turn is equal to x plus 3 whole thing squared minus 4 squared, and that is equal to x plus 3 plus 4 into x plus 3 minus 4, which is x plus 7 into x minus 1. This mathematical manipulation is called the completing of squares. Observe that the manipulation so far involved integers. It is possible even to have fractions either at intermediate or final stages. Carefully observe the identification of half the coefficient of x term marked in red. Then its square is added and subtracted to maintain the equality. Identify one perfect square and the remainder of the terms marked in green, and that happens to be a perfect square. Finally, we have a difference of squares. Applying the standard identity and simplifying the result in obtaining the factors. Revisit the identity x squared minus y squared is equal to x plus y into x minus y. Now, is this applicable to say x squared minus 8, where 8 is not a perfect square? Irrational numbers may be used if some numbers are not perfect squares. Since 8 is equal to square root of 8, follows that x squared minus 8 is equal to x squared minus square root of 8, which is equal to x plus root 8 into x minus root 8. Observe the following factorization. As in the previous example, half of the coefficient of the x term is marked in red. Then its square is added and subtracted to maintain the equality. Identify one perfect square and the remainder of terms are marked in green, and that is not a perfect square. Finally, we have a difference of squares is made out of 2, since 2 is the square root of 2. Applying the standard identity and simplifying results, the factors are computed. Now, what about x squared plus y squared instead of x squared minus y squared? Imaginary or complex numbers too are used in making out a difference of two squares. At junior school level, you would not have heard of this but must be told to answer the question. What is the value of square root of minus 1? It cannot be computed using known numbers. Hence, the symbol I is used to denote square root of minus 1. Hence, square root of minus y squared is equal to square root of minus 1 into y is equal to iy. Carefully note the following derivation. X squared plus y squared is equal to x squared minus of y squared, which is equal to x squared minus square root of minus y squared, and that is equal to x squared minus iy whole thing squared, which in turn is equal to x plus iy into x minus iy. As in the previous example, half of the coefficient of the x term is marked in red. Then its square is added and subtracted to maintain the equality. Identify one perfect square and the remainder of the term is marked in green, and the remainder is an addition instead of a subtraction as before. A difference is made out by subtracting a negative number. The square root of that negative number is I. Now the result is factorized using the identity on difference of squares. The following derivation is reproduced for comparison. In the above example, the quantities in green are imaginary numbers, and in the example below, the quantities in green are irrational numbers. Now, if the quantities marked in green are negative perfect squares, then there would be no separate numbers marked in red and green within the factors as seen in the factorization of x squared plus 5x plus 4. This is the end of part 2. The use of irrational, imaginary, and complex numbers can be mind boggling to students of junior school level. However, a reference to the same is a requirement to understand the answer to the question raised. We have come to the doorstep of answering the original question. Please do view the rest of the parts to find the answer to the question raised.